But I hope if it helps one of you, it's worth it, I think. But I'm sure you're gonna start thinking about it more. Okay, so sinusoidal functions. Okay, that's the last type of function we're gonna talk about. And yes, you can think of a repeating wave. Okay, so this applies best to events that tend to repeat themselves, like the tide, the ocean tide, right? It goes high, it reaches its highest point, then it goes back down, and so forth. When a tire spins, think of a tire having a rock stuck in the threads. If you were to graph the height of that thread as the tire rotates, it would also do this, right? So paddle wheels, anything that keeps repeating itself will. This is what you can write down. This is also known as periodic functions. Cycle, repeat. So that's where this function is best used when things keep on repeating themselves. Like the sun, the amount of sunlight per year changes on a daily basis, right? It increases, it increases, it increases until you get that peak. What is it? June. The longest day is June. Is it 21st? I might be off. But then after June 21st, the days start getting shorter and shorter, right? Until you get to that shortest day, which is going to be in September, October, some point, right? Then it's the shortest day, and then no, actually December. What am I talking about? It's December 21st is the shortest day, right? And then it goes longer. So we can actually predict the amount of sunlight at any time of the year, any day of the year, based on this function. Okay, let's keep going here. This is where you're gonna have to. I want to make a big note here. Change calculator. I'm gonna to radians. I'm gonna mention that a bunch of times, but we need to make sure we change this. Okay, so grab your calculator. Everybody, make sure you do this, otherwise your answers are going to be completely different. We're going to go mode, press mode, and where it says you have a choice between degrees and radian, we're going to pick radian. Okay, so hit enter there. And then when you quit, you should see radian at the top of your screen. This one is very hard to change, so it shouldn't change on its own, but just make sure you do that, okay? What is a radian? A radian is an alternative to express the size of an angle. What have you been used to describe the size of an angle? We would use degrees. Radians is an alternative without the degrees. Okay? And it's a number without units. So you gotta kind of imagine we're gonna go to the coordinate plane. So if this is the y-axis, that's the x-axis. Okay. A full circle, right? If you were to talk about degrees, we would start at 0 here and then go up, and then this would be 90, right? That's a 90 degree, and another 90 would bring us to 180. Another 90 would bring us to 270. Can you see that? Yeah, 270, and then we're back to 360. So a full circle, if you go by degrees, would be 360 degrees. If you go with radians, this would be 0. And what we know is that, you ready for this part? A full rotation would be 2 pi. So we go slash 2 pi. Yes, the pi you use for your circle. Yes, that's the one we're talking about here. So like a full circle is, we start at 0 radians. So this is radians, and this is degrees. Right? We will no longer be using degrees. We'll be using radians as our angle measure. So if you get to all the way to 180, this would be pi. So this up here, a 90-degree angle is the equivalent of pi by 2. pi, like half of pi. So basically what you're doing is you're going half a pi at a time. You're eating half a pie at a time, okay? If you're like me. So 0 pi, half of pi, full pi. If you add another half to a full half, that's 3 pi over 2. And then back to 2 pi. I'm going to highlight the radians, okay? That's the one we want to focus on. It's almost like we would like to go back and now erase the degrees, but we're not going to do that. And that's, I think I'm just going to stop there. Like we could spend a whole day on radians and why it is, but it's just an alternative method without using degrees to express an angle. So how much is pi? Anybody know? Remember 3.14. So think of this would be pi divided by 2. So this would be 3.14 divided by 2 would be 1.7 something. This is 1.7, the equivalent, but we just write it in terms of pi because it's easier that way. All right, let's keep going because I want to go into graphing these things. That's where I really want to go. And remember, we're getting ready for word problems. Stop, change from degrees to radians. You already know that, right? I'm just going to highlight it anyways. We deal with data that appears to have a repeating pattern on regular intervals. And so, again, I'm going to say that one more time. We're in the periodic functions category because cosine is also periodic, but we're not talking about cosine in this course, okay? Cosine is a different course. So these are the key terms here that I want you to know, and I'm going to use a different color for it. So you have what we call the period, okay? It's the time it takes for a full cycle to complete. Okay. It can be determined in several ways. It depends what information you're provided with. This is stated as a positive value. Sinusoidal function, I'm just going to say, right, that one, I'm just going to say that that's a sinusoidal function in general looks like this, but we're going to have many added components to that one. That's the most simplest form of it. Then we have what we call the midline, or what we can also refer to as the median. It's the horizontal line halfway between the maximum and the minimum. Okay, I'm just gonna leave that like that, but I want to give this a green here. Then next, there's the maximum. It's the highest value the wave achieves, and minimum is the lowest value. I'm running out of highlighters, but I think I can manage. I'm gonna give that blue. Okay. There's the maximum, there's the minimum, there's the median. I'm giving those 3 different colors if you can. And I thought I had changed this already, but I want to be specific, okay? Make sure you add this change. The maximum is the highest y value, okay, y value. The minimum is the lowest y value. I have to change that. There we go. The wave achieves. So we're talking about y values here. And then the last one is your amplitude. The amplitude. What is the amplitude? The distance from either the midline to the max or the midline to the min. That's what we call the amplitude. It's always a positive value as well. Okay. So here, I'm going to give you a short little visual. So when you review your notes, you know what I'm talking about. So if this is your wave, the midline is in green, okay? So you got to imagine there's a line that cuts this thing in half. The amplitude The amplitude is measured from the midline up or from the midline down. So, and it stays the same. It's always the same. It doesn't matter which one you would pick. The distance is the same. Okay, that's the beauty of this. And then the maximum, I put orange. So all of these points at the top here, the highest points. So you're thinking of a parabola. It's like the max, right? Except for this one has many of them all across. So that'd be orange. And then the minimums would be the lowest points here. And they just keep repeating as well. The lowest point is the same. Once you know this one, you actually know this one as well in terms of the y values. So I hope this visual helps you. Here is this, I would strongly recommend you add to your study sheet. This part right here. Try to make it smaller, but very important to understand the sine function. Just keep in mind that A, B, C, or D could be absent. Except, sorry, A has to be there. Has to be 1. It can't be 0 because if A be 0, all of this is 0. But you could have some other ones missing. B cannot be 0 either because then X would be gone. So A and B, I guess, have to be there, but C and D are optional. Okay, so A tells us the amplitude. Right? A will give you the amplitude of this function. So it's nice that it's also called A. What does this number in front of X do? It affects the cycle or the period. Okay, we will use that to figure out the cycle or the period. C affects the horizontal shift, and D affects the vertical shift as the function. So think of it this way. I'm going to talk about D here in a very concrete way. So if this is your sine wave and that's the original midline, if you were to raise, I need a blue pen here, there we go. If you increase D, if you make this bigger, your whole thing would actually be higher up. So it would match it, but it would be higher up if you increase it. If you decrease it, obviously, right, you would have a lower curve, right? Decrease, increase. And what does C do? C affects your horizontal shift. So I will try to fit another one in here. So if this is your original sine wave, C can shift it either left or right. So you would technically, if you shift this over just a little bit, you copy it, but you're off centered, right? You can shift it right. In this case, it could also be shifted left, but it gets too complicated. So just make sure C and D, what do they do to the function? How do they change it? It's important for you to know it. The amplitude, right? This is how it would change it. So this is our original function like this. If you were to increase it, you would all of a sudden have the waves would be further up like this. Okay, like the amplitude, the distance between the midline and the top would increase if you were to change A, right? Changing A increases, makes this sharper. And B, here I want to be careful. Yeah, I'm going to try this. If you increase B, your it's going to compress it more. It's going to be a lot more compressed. If B is decreased, it becomes a wider curve like this. It affects the period, how often something occurs. Okay, so if you're measuring the height of a pebble stuck in a tire thread, right? If you drive really fast, the height is going to change very rapidly versus if you just roll slowly through a drive-through, it's going to do this slowly, right? The change is going to happen slower. So that's what B does to your function. I'm going to just show you here, give you a visual. So this is my sine wave there. So A here is the amplitude. So watch what happens if I increase it. If I increase A, right? Imagine your midline is right here. The difference will be higher. And if you decrease it, it'll make it smaller, right? So that's what A does. It increases the amplitude. Watch for B. If you increase B, it becomes narrower. If you decrease it, oops, that's a straight line, but then you make it wider. C will shift it. Look at that. Right? So there you go. That's what C does. It shifts it sideways, and D will shift the whole thing either down or up. That's what that does to it. Okay. So if I look at I'm also going to label the midline right there. If you increase it, the midline comes with you. Right? The midline follows the curve, and it's halfway between. All right, I'm going to stop that there. I think you had enough fun already with this. Not. Okay. Here are some formulas that you should know. Okay. I'm going to focus on, which one am I going to focus on here? For the period, I want you to box this one, and this one is important. X max 2 minus X max 1. So you're going to figure out there's going to be two X values for the two highest points, and when you subtract them, you get your period. Okay. This is the other one I want you to box in. These are important here. I will say this. Use when equation given. Okay, when you're given the equation, use this one. This is probably going to be the most popular way to find the period of the function. This one is when graph is given. When graph, what happened there? When graph given. Okay. So these two, I would say, are must-haves. But if you can fit the other ones, go for it. Okay. Amplitude. The amplitude is found both ways. Okay. A is equal to y max minus the midline, or A is y max and the y min. Like you subtract those two and divide it by 2. Or this is the best one. Just get A from the equation. Like if you know A, if you know the equation, that is your amplitude. No need to do these formulas. These formulas are just there when the graph is provided, right? Or partial information. Equation of the midline, you would basically notice the difference. Y max plus Y min divided by 2 versus the amplitude is Y max minus Y min, okay? Very important. But you divide them both by 2. Or just get D from the equation. That's probably the most popular, but this is there in case. You don't. Okay? The domain is usually x is part of all real numbers. And that's the set notation. This is the interval notation. It just goes, in terms of your x values, it goes negative infinity to positive infinity. I want to show you the one that, no, I'm going to do that later when we do word problems. What about range? Range is a little different. You would figure out the minimum y value and then say that y has to be between that but less than the y max. Okay. It has to be between the y min and the y max. And interval would be y min and y max. Because remember, in terms of the y values, it's comprised, right? It just sticks within two values all the time. Just reaches the top, reaches the bottom, reaches the top, reaches the bottom. Like it stays within those two numbers that we will determine. All right. It's a little overwhelming. Once we apply this, some of you are not even going to think of the formulas anymore. Okay, but I would strongly recommend you add them. Here we go. I'm wondering if I'm going to skip this part and go to the equation first, because I actually think that's easier than to do one off of the graph. So I'm going to skip for now. And let's go to page 6, okay? Page 6. There we go. Always remember, okay, I'm going to make a note. Remember, there are several ways to determine characteristics. Okay, there's not just one way. You might, after a while, it's like, you know what? I know what the amplitude is. I'm just looking at the graph. I don't need to use a formula. That's all right. There's nothing wrong with that. Okay, so you should right away recognize this is a sinusoidal function because the sine is in there. Okay, so then you will say, okay, this is A. This value right here is B. This value is C. This value is D. In this case, all four are given. Remember, C or D could be 0. I hope you're listening. I know it's Friday. But sometimes C and D are missing. Sometimes you have some weird fractions in there. Don't worry about it. You have a calculator. Okay? So just keep that in mind. So to graph this, am I going to graph it? Yes, I want to, but okay, never mind. We'll get to it. So amplitude is going to be 15. We have no idea what the units are. This is just A, right? The next thing is the period. And to find the period, the easiest way is just to go 2 pi divided by b. It's the best way to do it. 2 pi divided by, in my case, b is 0.1257. We are going to, in general, state our b value to 4 decimals to have our very accurate period, okay? So you grab your calculator. All you need to do is you go 2 and then second hat brings pi into the mix. I don't know if it's been a while, right? And then we divide it by 0.1257. And it's 49.99. I wanted it to be 50. But whatever, it is what it is. What does this number mean? That the cycle repeats, sorry, repeats itself every 49.99 units. I would say along the x. So every 49.99, if you go along the x and you go from this to this, every 49.99, this thing is going to repeat itself. Okay. So we've got that. I don't know why I left you that much space because my key actually doesn't need that much space. I want you to now, we want to now fill in this chart at the bottom here. But I think I'll use that part at the top, sorry guys, to, if it asks you what's the equation of the maximum, okay, the formula is this. Max is going to be, I'm going to go back to my formulas there. Did I give you that? I didn't give you that, but it's this midline plus amplitude. Okay. That's how you find your maximum. The minimum is midline minus amplitude. The equation of the midline is just y is equal to d, or you take the max plus the min and you divide that by 2. The amplitude is just a on the equation, or max minus the min divided by 2. The period, we already did that, 2 pi divided by b. The domain and range, we're just going to state it. We're not going to come up with an equation for that because we just look at it at the graph and come up with it. Let's do a rough sketch before we answer this. Okay, I want you to just do this. Make a wave like this. Try to make it as equally spaced out as you can. It doesn't have to be perfect. But I want you to see what we're finding. Okay, so you've got your wave. Try to find the middle. Try to find the point where it's the same distance from here to the top and from here to the bottom. This is your midline. Midline is actually y is equal to d. And what is d in this case? It's -7. So that's the midline. What is our amplitude based on this equation? Amplitude is this. We're told that this is 15 units. Every single time from the top to the bottom. So we're going from the midline out. It's 15. Maybe you should do arrows, right? It always starts from the midline and goes to the top or bottom. So the amplitude, we can go A is equal to 15, right? And I'm going to use a different color. I'm going to use a red pen. The minimum goes along the bottom of this thing. And here we're going to have to do some adjustments if it doesn't touch it every single time. This is what we call the equation of the min. Equation of min, and the top, where's my blue pen? Did I drop that? Oh, yeah, I dropped top is the equation of the max. So you go up top. If it doesn't perfectly line up, I'm going to make changes to my graph here so that it does happen. That's the equation of the max. So and because I use pencil, I can just make this all work out for me. Right, I'm going to make sure that touches there. This touches down here. It's all good. And remember, it's always 15 from the midline to any extreme. Okay. How do we get the equation of the maximum? Let's do the maximum first. Would it make sense that you would just take the midline and add 15 to it? Right? I hope that makes sense to you. So we go max is going to be midline, which is -7, plus 15. And that's 8. Positive. So basically it's y is equal to 8. This is your equation of the max. Okay. The min, we go midline again, but in this case we subtract the amplitude from it. So this is adding negatives, right? So this would be -22. So y is equal to -22 is technically the equation of the min. So you can go over here and say, hey, I know that this line is a horizontal line that goes along -22. And the top here is a horizontal line which is equal to 8. What's the middle? I'm going to do this one more time. This one is -7. So everything, these three lines are very important to us. The minimum, the midline, and the max, because it's going to jump. We're always going to jump from the lowest to the mid, to the high, back to the mid, back to the low. That's going to be a very common pattern here. I'm going to wait a little bit to copy this all down. Just make sure you copy this. Okay, emphasis on that there are several ways of getting my answer. Okay, equation of the midline. I already know that the midline is -7, but let's say you didn't know that. Okay, pay attention to this. You would go max, okay, max plus my min divided by 2. And you all know that plus and minus, right, turns into minus. And this gives me a -14 divided by 2, yikes, right, which is -7. I already knew that. I knew that it was -7, but this is just to confirm, right, that if you didn't know what the equation was, you could have just grabbed the max and the min, added it up, and divided it by 2, and then you get your midline. Amplitude. We know it's A. We already know it's 15. But let's say you didn't have the equation. You just had the graph. I would expect you to know it's like, oh, it's max minus the min, right? You got to pay attention to the signs, divided by 2. So it's 8. This is really 8 plus 22 divided by 2, which is 30 divided by 2, which is 15. We knew that our amplitude was 15. It's all over the place here. Okay, so that just checks out. Period. This is the one we've used up there, okay, guys? But I'm going to say or. Which other one did I give you? Let's go and explore some of the other formulas. I told you x max 2. Can we do that right now based on what we have? We don't. So I'm just going to leave it like that. For now, this is limited information, so we're just going to keep it like that. So it's 2 pi over 0.12. Let's just copy it down one more time, which is 49.99. We know that that's our period. Our domain is just, let's go set notation here, interval notation here. Our range is, what is it going to be here? We're going from -22, that's the lowest this thing ever gets, and we're talking y value and it's the range, all the way to +8. Or we could go -22 to 8 like this. Just make sure you have square brackets, and that would be our range there. Let's go to 5 here. No equation given. Let's see here. Yeah, we'll do 5. Come with me to page 5. So we're going backwards in time. We're also going to do regressions here. Highlight that part. I don't want you to miss that. Sinusoidal regressions. So we're going to go stat, calc, which one is it? Stat, calc. Is it synreg? I'm pretty sure it's synreg. It's been a while. Yeah, synreg. When you do a sinusoidal regression, that's what you're going to be using. How many points do you need? You need 5 points. It doesn't matter which ones. I'm going to be strategic and pick the ones that are, easy to pick and easy to come up with. But here we go. I'm going to first focus on a few things here. What did I use for max and min? Let me just check. I used max orange, amplitude gray, which is not the greatest. Got it. I'm just going to use my own colors here. I'm going to use a ruler. The first thing that I want you to notice is that it does reach a high point. This one is drawn to scale. So this would be what you should think of as, I call this the max, but it's also the equation of the max. And then I'm going to use green for the bottom here. This bottom here is min, and it will reach that. That's the lowest it ever goes. This is going to be y equals, and this is going to be y equals. We can just tell by the graph, what is this one going to be? I purposely put everything in the negatives. This would be -13, correct? Because right here, we're at -13. So -13, this is the max, and this is the min. The min is negative what? -27? Can you guess what the midline is? I think you can see it, but don't guess. If you're not sure, don't guess, because we're just going to figure this out here. Equation of the maximum. I don't need a formula. I'm just going to go y is equal to -13. These are the characteristics, by the way. Equation of the minimum. We know it's -27. Equation of the midline. I'm going to use an equation. So mid is going to be max plus min. Remember when you do the average of something, you just add it up and divide it by the number of numbers you're adding. Okay, that's what we're doing here. We're finding the average between the highest and the lowest. I would strongly recommend you put brackets there. Mr. Reason, couldn't we just go y equals d? Because I have that on my study sheet. We don't have an equation, so you can't, right? You don't have an equation. So we're going to figure this out. So mid is going to be negative 13 plus negative 27 divided by 2. The top gives you negative 40 because you're adding negatives, really, divided by 2. So that's negative 20. Okay. That, can you see that? It's a little on the high side. That is my midline. So I'm going to go and I'm going to grab orange. No, maybe I'm going to use a red pen for this one. I'm going to do amplitude. I'm going to use orange for that one. So I'm going to go to negative 20, which you could probably have guessed that it's that is our midline. But remember, these three heights, so to speak, go ahead, are very important. This is my midline. That's y equals to negative 20. And the amplitude, let's highlight it here. This is the amplitude. Then we go from the midline straight to the lowest point, and from the midline straight to the highest. So it doesn't matter where you find it, just determine that it's constant. Mr. Dirksen, my study sheet says amplitude is A. You don't have an equation, can't use that. But I have a formula which is very similar to this. It's max minus min divided by 2. Mr. Dirksen, could I just count it here? Can I just count? Yeah. Use whatever is at your disposal to do it, right? But you won't always have a graph. So amplitude, maximum is negative 13 minus the lowest, which is negative 27. I'm going to divide that by 2. This is really negative 13 plus 27. So that would be 14 divided by 2. So amplitude is 7. Let's double check. 1, 2, 3, 4, 5, 6, 7. Voila. Right? So I think you're going to start seeing patterns. And I know it's a little overwhelming because I'm just dumping a lot of information on you. Just practice this. And what I'm trying to emphasize is that there are several ways to verify that you're doing this right. You shouldn't just blindly take your numbers and be like, yeah, I'm just going to go with it. Okay? Period. 2 pi divided by b, Mr. Dirksen, because that's what I have on my study sheet. Is this going to help you here? Do you know what b is? Nope. So which other formula? Or allow me to introduce this one. X max 2 minus X max 1. Like, what is this mumbo jumbo here? What is that? Well, look up here on the I'm gonna pick this point here. I'm gonna call this X max 1 because that's the X. You're with me, right? That's the X coordinate of the first max that I'm identifying. I'm going to ride the wave. Come back up. There's another instance here. That's what I call X max 2. How is that going to give me my period? Well, after a full cycle, right? After this, it repeats itself again and again and again. So a cycle is the distance between points where afterwards it repeats itself. So this distance, the horizontal distance, is the period. So you could have picked these 2 points, those two, it doesn't matter. Just pick 2 that are within the cycle. So I'm gonna say, what is this, guys? Let's help me out here. This is -5, correct? Is -5. And this one here is 11. Write this down, make sure you have that there. So I'm going to go x max 2, 11 minus -5. So that's 11 plus 5, which is 16. Let's just write units, right? It's going to be hours. It's going to be meters. It's going to be something down the road. And you just want to make sure you have that. Sorry, it was way at the bottom of the screen. Please let me know if I'm off screen here. So these three here, I resulted to a formula. The first two, I did not need one. I just read, right? I'm just going to say read and read, right? So these ones, I just straight from the graph. I didn't need a formula for that one. Okay, domain and range. Domain, you can close your eyes, right? You just go like this. You already know that that's going to be the answer. I'm going to go negative infinity to positive infinity. This will most likely stop after a while being infinities, but it's going to be quite common. What's the range here? Always the lowest first, right? So from negative 27 all the way to negative 13. So y is between these two numbers, but including the numbers themselves. So that'd be negative 27 to negative 13. And now the equation of this wave. This is the fun part. I don't know about you, Mr. Dixon, your definition of fun is not necessarily accurate, but that's okay. Okay, so here's where I want you to start thinking of patterns for sinusoidal functions. I'm going to do this work for this equation. I'm going to do it up here in the corner, like on the side here. You're with me? Let's go up slowly. How many points do we need? 5, right? 5 points. So we're going to go x, y. We're going to find 5 points on this graph. I'm going to start with this one here. It doesn't matter where you start, but I'm going to pick 5 consecutive points starting here. Okay, so this is the negative 5, negative 13 point. This one right here. I'm going to write this down, negative 5, negative 13. Then I'm going to ride the wave and go to my next point of interest, which is this one right here. It lands on the midline. This point right here is negative 1, negative 20. I know the y value because I'm on the negative 20 line. So I'm going to write that down. Negative 1, negative 20. Ride the wave again and go to the lowest here. This is 3. I had to work hard to make it land exactly on, because we're going to use our calculator to find these points as well. So 3 negative 27 goes next. 2 more to go. Ride the wave again to the next line of interest, which is right here. That point right here is 7 negative 20. 7 negative 20. Hey, we're back at negative 20, Mr. Dixon. Yeah. And then one more up top here. That one is 11 negative 13. So you put this down, 11 negative 13. You type this into L1, type this into L2, stat, calc, sine reg, and let's come up with our equation. Remember how to do this? There we go. Then I'm going to go stat calc, and I'm going to go all the way down to synreg, which is C, right? Option C. For me, it's easier to just scroll down. I'm going to hit enter. Second 1, comma, second 2, comma, alpha trace. Alpha trace. Boom. There we go. Let's see if we can confirm some things here of our findings. Would we expect our A to be 7? Our amplitude is 7, correct? Okay, we're doing good. Sine, you just basically copy, it has the format up here, and you just insert the numbers. So we're going to go 0.3927x. I go 4 decimals for the b value, minus 2.75, close brackets, minus 20. Does it make sense? Negative 20, this is our midline right here. It's right there. Amplitude is 7. We've determined that amplitude is 7 down there if you look at it. So this is 7. This measures 7, right? Every single time. So we've identified that as well. How do we find our max? I know I'm going to now maybe give you the formula. To get the max, if you have the equation, it would just be midline plus the amplitude. If you want the minimum, you take the midline, you subtract the amplitude from it. So these two at the ends here quickly tell you what the highest and the lowest points would be. Okay? So it's all connected. I'm just going to go arrow from here all the way to the bottom where it says equation. I'm just going to say, hey, we did that here. And that's where it's supposed to go. And so these two pages are very much connected. Like if you look back and forth, we did one with the equation given, one is without the equation given. Okay. All right. Let me see here. I'm going to ask you to go to pages 9 and 10. Okay, you're going to go to pages 9 and 10 and practice this. So there are two graphs on each page, right? So you do the work for both of them. And both of these do not have an equation. You're going to have to find that at the end. Right? I'm asking you to figure out the equation, but first figure out everything else. And then at the bottom here, come up with your 5 points, right? Somewhere in here to come up with this equation. Then come up with your 5 points here that will allow you to find that equation. And please always jump between the max, the mid, and the min. That is very important, right? So actually using highlighters, identify the highest and the lowest, determine the midline, right? Sketch it, and then you kind of, wherever you start, you want to start either on the low, on the mid, or on the max, and take 5 consecutive points for your equation, okay? So that's what I'm going to ask you to do right now. That's going to be the end of today. If you could just make sure you do 9 and 10. I think I'm also going to go back to the one I skipped, pages 4, 9, 10, but for now just focus on 9 and 10, and then we'll come back on Monday and review graphing on paper, okay? Thank you guys. Except for lead. Don't buy lead there. That's why it breaks all the time.